Hi everybody, this is Rick Hooper. I'm president of Quasi, welcoming you to our virtual workshop on field data management solutions. We have a great speaker today, Wade Sheldon, and if you want to show next week's speaker is going to be Corinna Grease and Don Henshaw, so mark that in your calendar for next week, but I'm sure that Emily will be sending you an email nonetheless, so no worries there. So we're continuing the series. Today, our talk by Wade comes to us from the LTER program. He is the scientific computing professional in the Department of Marine Sciences at the University of Georgia, where he specializes in environmental data management, ecological informatics, and database system design. He's done a lot of work with the LTERs over the year and has a lot of experience to share with us. He's currently serving as a lead information manager for the Georgia Coastal Ecosystems LTER and the Savannah River Ecology Lab, SREL. Coordinates web and database resources for the Georgia Coastal Research Council and the Sapelo Island National Estuarine Research Reserve, which is the UGA Marine Institute. So with that, I'm very pleased to turn it over to Wade to have him talk about the GCE Data Toolbox for MATLAB. Thanks. Wade?
Thanks, Rick. I'm going to try speaking using a speakerphone in my office, so if there's a drop in sound quality or people are having a hard time hearing me, just let me know in the chat box and I'll switch back over to the handset. Okay, so today I just wanted to give you a brief introduction to some data management software that we've developed for our LTR program that has grown in sophistication over the years and has now been released as an open source software package for MATLAB, and it is gaining pretty wide acceptance in the LTR network and outside LTER as a very practical tool for managing sensor data as well as lab data and other common types of tabular environmental data. Just to give you a brief bit of background, our LTR program started back in 2000, and those of you who aren't familiar with LTER, this is a large and varied research program. We have about 20 investigators in their labs participating, and we have a very diverse data collection effort as part of this program. And National Science Foundation and LTER have very high standards for data and metadata archiving and sharing, and so we knew we needed to standardize on data processing approaches as well as quality control and documentation to keep up with this large research program. We surveyed what was available back in 2000 and didn't really find any ready-to-use software for something on the scale of an LTER data management. A lot of good papers, a lot of great reports, but really no tools we could just pick up and use. And people were just starting to get into custom relational database systems and doing some good work in that area. But those were fairly proprietary and complex and required some constant network access, which is a problem for us in our field site. So we decided to develop a custom data management framework using MATLAB. We had a lot of experience developing automated data processing pipelines and graphical user interfaces using MATLAB at the time, so we felt this had a better code reuse potential than a custom database web solution. And it was a good compromise between file-based systems and also fully dynamic systems. So we thought that would be a good way to proceed. And for anyone who is not familiar with MATLAB, it's a very comprehensive programming environment for algorithm development, data analysis, and visualization that is really prevalent in a lot of fields of study, particularly in engineering and financial worlds, but also a lot of science branches, particularly physical science. It supports rapid software development, a lot of pre-built functionality, integrates nicely with Java, and a major benefit for us is the code you write as well as the applications and the data formats work very well cross-platform, so you don't have to worry about your target audience. It's also very stable, it's a 30-year history, and scales from everything from a netbook to a high-performance computing cluster. So felt this was a tool that we could grow with as we went forward. The only downside is it is commercial, and they follow kind of a licensed source model where you pay a perpetual license fee and then you get access to a large body of software, a source code that you can modify if needed. But that, as compared to open source solutions, it does limit your flexibility and can cost a little or a lot depending on how you get the software. And also, like many of these technologies, a little bit of programming is required for maximum use. But on balance, we thought this was a very effective solution for us. Okay, so where we began this process was by starting with the Ecological Society of America's Future of Long-Term Ecological Data Report to really get a deep view of what should go into a data management system with a focus on long-term data accessibility and archiving. And we identified from these guidance a lot of information storage requirements, the kind of metadata that we should really be tracking for all the variables in our environmental data, the need for versioning and quality control as an intrinsic part of the data that we manage. And so with these requirements in mind, we designed a very comprehensive tabular data model in MATLAB with fields for every class of information, detailed specifications for this model, following a virtual table design where we wanted to build something like a relational database table, but track along with the data, all the various descriptors that we really need to interpret it for environmental data, units and units of measurement and variable types and semantic information as well as quality control information. So something that we could really keep these together. And I won't go in, there won't be a quiz on this later, but I just wanted to throw up a conceptual diagram of what this model looks like. And as you can see, there's some general data set level metadata that store information about the actual structure itself, as well as the lineage, the data processing history, which I'll describe a little bit later, and general documentation level metadata. And then there's an unbounded series of data attributes or data columns that include matched arrays of data values and qualifier flags, and then all the attribute metadata required to interpret those. And so this is just a conceptual view of what gets stored, but you don't, with this software, you don't really have to know these details or interact with this data model. This is just the guiding principle on which the software is based. Okay, so of course, a data model is all well and good, but it's not very useful if there is no software that knows how to work with it. So we developed a library of MATLAB software code, a toolbox in MATLAB parlance, to let you work with these data stored using the specification. This includes utility functions to abstract all the low-level operations, basically an application programmer interface, as well as for things like creating structures, adding and deleting columns, and copying and inserting and deleting rows, and also extracting the data out of these structures and sorting and querying the data, as well as updating data and updating qualifier flags. So those are all handled by these low-level API functions. But then we've developed a growing body of analytical functions for high-level operations, things like performing statistical analysis, visualizing data, doing high-level geographic and date-time transformations, as well as unit interconversions, aggregation and resampling of data, and joining multiple data sets to form integrated data sets. So all of those things are part of this toolbox. Also, over the years, we've developed a fairly comprehensive suite of graphical user interface functions to simplify using the toolbox by non-programmers. And an important note is that all of the functions in this toolbox use this metadata and data introspection from this model to auto-parameterize and automate a lot of operations. So it's really going for kind of a semantic processing approach where the metadata guide what is done with the data. So we've also developed some indexing and search support and a graphical search engine for this software so that you can manage and find the data that you've worked up using this tool. That's also useful for some of the other things I'll be describing later in terms of publishing data. And then we have also developed and packaged some data harvest management tools to automate using this software in a kind of a production environment with ongoing data collection. Okay, so for people that are comfortable working with MATLAB, working with code, and wanting to work interactively with these data, there's a very rich command line interface that provides, lets you work directly with these using your own MATLAB programs or software functions that are provided with this toolbox. But for people that are less comfortable working on the command line, there are graphical user interface applications that let you do virtually all the operations of this toolbox without even looking at the MATLAB command line. So you can start up the software, work in a graphical environment, and shut it down without ever seeing a command prompt. So it's been very very successfully utilized by people that really don't know hardly anything about the MATLAB environment except about how to start it. So to give you a bit of an overview of the capabilities of this toolbox and what you can do with it from a field data management perspective, I wanted to describe some of these features in the context of a typical data management cycle, where we're starting with raw data and then importing data into the analytical environment, getting metadata in, doing quality control analysis, post-processing, synthesizing data, and eventually archiving or publishing the data. This is the kind of a typical environmental data pipeline that most environmental data management programs are oriented towards. So this process obviously starts by bringing some data into the environment. I'm not going to talk a lot about the raw data piece. If you're interested particularly in the sensor data aspects of this, I encourage you to tune in next week to Don and Corinna's talk on sensor data management or sensor management best practices. But for today, we're going to start with the point of importing data from a sensor network or from some network data source or some means of bringing in environmental data that you want to analyze. Okay, so this toolbox has very broad support for bringing in tabular data from a wide and growing variety of sources. So as I said, this has been used for general data processing for a very broad LTER site, actually several LTER sites. So there's a wide compatibility with a lot of the common environmental data that we're all used to working with. There are generic parsers for delimited text files, either well-behaved logger files or just things that came from other programs that you use or from spreadsheet-type programs. As well as if you are working with MATLAB, you can also pull in data from conventional MATLAB variables, including arrays and matrices and structs, so that you can bring in data that way. But it's very often the case, as I'm sure a lot of people are familiar with, is that sensor vendors particularly like to make specialized formats for their data that make it difficult to work with in MATLAB or R or other structured data environments. So we've added a wide variety of vendor-specific logger file parsers. Some of the most common ones that are used are the Campbell Scientific Instruments loggers, so we can parse the table-oriented ASCII files as well as the variable-length array files. And directly, you can also process, we work a lot with seabird instruments for marine instruments, so you can process their conductivity temperature depth profile data, SON data natively, as well as a lot of other specialized environmental sensors from Hobo, Schlumberger, OSL, and others. So those are really useful to save you the trouble of trying to get data out of these highly specialized formats. But increasingly, we're getting a lot of our data from network sources. This can include SQL database queries. For example, if you're running Campbell's LargaNet DB to get your data from the sensor networks right into a database, or if you're using a data turbine, MySQL connector, or some other source, you may have your data coming right directly into a database system. So you can basically pass in a query, get the data back out into this framework. Sometimes data is actually managed through the USGS National Water Information System or NOAA servers. So we can also pull in data directly from those web services, and LTER climate database and hydrology database as well. And also in the case if there's data that you want to work with that's in an ecological metadata language repository, the LTER Network Information System or Knowledge Network for Biocomplexity or some other Data One resource, it can also pull data directly out of those, as well as last year we added support for getting data directly from a data turbine server. So those are all make it very practical to get data from a wide variety of sources, but there's also tools that are provided for building your own custom parser and plugging that right into the toolbox. So when you first start up the software and get ready to import the data, first thing that comes up is this data structure editor window, which is essentially the control panel for your data sets that gives you access to a lot of the operations and menus for working with the data. And then you can select one of the provided import filters to get data. In this case, I've selected import data from the USGS NWIS, and it brought up this form where I can select a station by site and then what type of data I want over what period of record, and it'll go get it for me. Similarly, this is a configuration for Campbell logger file where I've used the built-in Campbell TOA5 or table-oriented ASCII data import filter and set up some parameters. And this, by selecting a menu item, you can pull data directly from a Campbell logger file. So once you've chosen one of the import filters and pulled data into the environment, then you'll see that the dataset gets loaded into this dataset editor window, and you can see the list of all the variables that are present in the data file, as well as some controls for operating on them. And clicking on one of the variables brings up the attributes that you can look at or revise in terms of name, units, and description, as well as data type and variable type and so on. There's also a very complex series of menus at the top that you can use to launch various analytical tools or fill gaps in data or deal with manipulate the data in other ways. And then if you select view edit the data, it instantiates a data table you see over to the right that lets you visualize flagged values and other things and actually revise values and work with the data directly. So this is like the first step in getting data into the environment is it populates this graphical structure, the viewer, and then you can launch various analytical tools from that point. Okay, so that's the quick whirlwind view of getting data into this framework. And if you're working from the command line, you would basically be retrieving this fully populated data structure, directly as a variable in the MATLAB workspace, but it will work very similarly. Okay, so the next important step is providing some metadata for these data so that we can interpret, what these variables represent, and that there's enough information there along with those variables for various types of analyses and for post-processing. So that's another important step of any environmental data management. As everybody knows, I'm sure it's a big open secret in the informatics community, metadata entry is very time-consuming and tedious. So it's often said that necessity is the mother of invention, but in my book, the father is laziness. So I really don't like writing metadata, so there's a tremendous amount of functionality in this toolbox to help minimize the necessity of typing metadata. So this software strongly emphasizes metadata capture and reuse, and well as metadata auto-generation whenever possible. So our motto around in my shop is friends don't let friends type metadata. So this is really a very important philosophy of the software design. And so consequently, there are many pathways for building metadata in this toolbox. So metadata can be imported right along with the data when there's metadata provided. And this includes some of the information in data logger header files that are provided with CBIRD data and Campbell data, things such as sensor IDs and calibration dates and program versions and units and such. Also, when you pull in data from USGS and NOAA, the software includes all this information on stations that are provided by NWIS and by NOAA. And so when you bring in data, it queries all that station information and pre-populates all the metadata for where the stations are and characteristics. And also, if you are working with spreadsheet users, the software comes with a data submission spreadsheet template that if the users fill that information out, then you can bring all that metadata in along with the data that are exported from that template to save you the effort of having to build all the metadata. But in some cases, it is necessary to augment the metadata you get from these sources to really complete it. And so when that's the case, if you've already put that effort in, then a good pathway is to just import that metadata from another data set that you've already processed. So you can import all or selected portions of metadata from existing data structures that you've already generated. And also, if you're bringing in data from a data repository like LTER or on one of the Data 1 nodes, then the EML metadata will bring in all the metadata as well. But a good facility that works really well for repetitive data processing is to build all this metadata into user-defined templates. These are combinations of column or attribute metadata that are matched to the variables that are present in the data source, as well as boilerplate general documentation describing just the research origin and methods and such that go with the data. And there's a graphical user interface tool for creating and managing these templates And that's a very efficient way to be able to provide metadata for raw data that you're bringing into this environment. This is a screenshot of the little console for the form for working with these metadata templates, and there's a large list of those that we've defined for GCE, and each one of these named templates includes associated documentation metadata as well as detailed metadata for all the data columns, including, code lists and quality control rules and all those other things I'll be describing shortly. And then there's a wide variety of tools for actually managing these templates, and then you can, copy metadata and synchronize rules and all these other things to really keep these things, make them very easy to work with and transfer between users and share them to save you all the effort of having to, create metadata from scratch to work with your sensor data. So this has grown up through a lot of use cases for a lot of years, people trying to minimize the amount of time minimize the amount of effort and maximize the value of having metadata. So I think that's a very important feature of this software. And this is just a view of the actual documentation metadata editor. It's a very simple, lightweight form for filling in general documentation information. Okay, so moving on in the data management cycle, another critical element of any environmental data work is quality control. We all know that, particularly as more environmental measurements go to automated sensors, that the potential for data contamination or junk data or collecting data under unsuitable conditions is increasing rapidly. So this software, this is probably one of the most powerful features of this software, is this dynamic quality control and quality analysis framework that it provides. So one of the most important features is the support for programmatic quality control analysis. You can define rules or criteria that define the conditions under which values in every column should be flagged. You can have an unlimited number of these quality control rules for every variable, and then these rules are evaluated whenever new data are loaded or when the data or the rules themselves are changed. And you can predefine these rules in metadata templates to fully automate quality control when you load new data. So these rules are not limited to simple limit checks and other things that just inspect the values of that one variable. They can reference statistical tests, data throughout the data set. They can run external functions or models or look up external data. So it's really very open framework. If you can think of a use case for performing quality control on environmental data, it can probably be implemented pretty easily using this framework. So it's been proven to be very, very flexible. But of course, as anybody has tried to do automated QC knows, you can never get it quite right. There are many times where you're over-flagging by hitting unique events in your data, or you have missed some strange set of conditions, and there's always the need to revise QC analysis at some point in the data cycle. So this software also provides very comprehensive capabilities for interactively doing QC analysis. For example, you can assign and clear qualifiers right on data plots using the mouse. You can also, once you've done quality control on primary measurements, you can propagate those to all the dependent columns that are calculated based on them. For example, perform quality control on temperature and pressure and conductivity, and then propagate those flags to salinity. Qualifiers can also be removed or edited if standards change, because not every organization uses the same qualifiers and things change over time. So you can go back and revise those without actually going back and redoing all your quality control checks. Another important feature is automatic documentation of these QC steps. All these operations, including revisions to data and flags, are logged to a processing lineage. And you can also auto-generate a data anomalies report to go with the metadata describing, what flags are assigned to variables over date ranges. And the last feature I wanted to call out is that the data analysis and synthesis tools that are provided with this toolbox are all quality control aware. So the real missing link in a lot of environmental data management software is that qualifiers can be assigned a wide variety of ways, but very few, if any, software tools know how to interpret those and give you choices that are convenient for actually using that quality control information when you do your analysis. So in this software, all the tools that are provided understand the data model, understand the quality control structure, and so as you're analyzing data, you can choose to filter out qualified values that meet different criteria, or the qualifiers can be summarized when you're downsampling data, and visualize qualifiers when you're analyzing data for plotting or exporting it. And you can also use statistics about missing and qualified values when you're generating derived data, and that's something I'll talk a little bit more about shortly. But so it's a very comprehensive suite. I could do an entire workshop on this feature alone, and there's some documentation on the support website to get you started. But this is a big topic area, but it's an important one for important use case for this software. Okay, so in this case, a little strange graphical blip there from the, the widget, but as you can see, returning back to the view of the data set that's been loaded into the environment, you can see the flag criteria field at the bottom for the salinity attribute. Well, clicking on Edit brings up a form for editing and working with quality control criteria that you can go add and revise, either limit checks or complex equations or relationships, or bring in external functions to perform very specialized quality control operations. And then you can manage those. Those get reevaluated whenever the rules change to reassign or clear qualifiers on the salinity column in this case. And this same form can be used for, interactively as you're working with data. You can go and tweak the rules and see the effects, or you can also use the same tool to define quality control rules when you're building a metadata template. So it gives you a convenient way to really evaluate with these rules. So the basic concept is you've got some condition that's matched, and then you associate that with a qualifier to assign. And then you can edit. There's no fixed language of qualifiers. You can define your own qualifiers based on your programmatic needs, and then and work with those. So and there's also no real semantics that are assumed. You can use qualifiers to identify good values or different processing levels or whatever makes sense for your data management program. But the most common case, obviously, is to call out problematic values that need review. But the flexibility is present to use them for whatever makes sense for your program. So here's a live example from one of our CTD moorings, where we have a real problem with conductivity sensors getting stopped up by debris. So we're using this quality control rule that's provided with the toolbox's function called flag no value change that checks for stuck sensors with various parameters, and so it's automatically flagging those stuck portions when the sensor got fouled. We're also defining rules that when the depth is too shallow, we want the salinity values flagged because the sensor's popping out of the water, and so on. So you can define these rules and just automatically flag the data right when you bring it in, and then you can work with it and refine the rules or refine the flags as part of your processing. Okay, so a real important point that kind of tie together the last couple points that I was making is that when you're using the software, once you've identified an import filter for your data and you defined a metadata template containing these quality control rules, simply importing the data into this toolbox will perform a major portion of your data processing in one step. And that cannot be underemphasized, how useful that is in automating, data that are coming in from an ongoing, data collection effort. Okay, so obviously, raw data are not the only thing of interest. As you go forward, you need to analyze data and look at ways to work with it, and you maybe integrate it with some other observations. And so the toolbox comes with a very broad suite of post-processing and synthesis tools. I won't go through a lot of them here, but I wanted to just mention a few of them. For example, you can easily generate derived data sets just by filtering values or refactoring data tables based on your needs. Once you've brought in data from the sensor, you can also resample the summarized data using aggregation, binning, or date-time scaling. The form to the right here is a date-time resampling tool where it automatically analyzes the time step of your data and gives you choices for how to summarize it, and then you can choose variables to group by and variables to calculate statistics for to generate resampled data daily in this case from 15-minute data. You can also combine multiple data sets by unions and joins to bring them together. In both cases, using the metadata to facilitate that and make sure that you're aligning the columns right automatically and checking for compatibility of units and such. And all the derived data that you generate using this toolbox form a complete, bring along the metadata and the processing history. So you're not just pulling out values once you've joined data together, resampled them. You're generating a complete data set from that operation. And another important point is that quality control rules can be generated for these derived data automatically based on the number or percent of missing or flagged values. And you can see the little form, the bottom of the form to the right, you can see these criteria that you can set. Those will generate rules for the derived data so that your summary statistics can represent how clean and complete the underlying data were when you're downsampling it. Okay, and last and not least, archiving and publishing data is a typical and growing part of the data management cycle that we all have to deal with. And NSF and other programs are requiring archiving as part of more and more grants. Journals are requiring archiving, so that's an important part of the data life cycle as well. So the GCE Toolbox does have a variety of ways that you can work with you in helping you archive your data. Most recently, we've now added support for ecological metadata language generation from the toolbox. So you can publish both the data and structured XML metadata directly from this toolbox to deposit into the LTER network information system or a Data 1 member node or other repositories like Dryad and others that are coming along. So this is important because it used to require you to basically export your metadata and data into some other framework to be able to publish it. Well, now that can be accommodated just using the software alone, and that's a real improvement. Also, the data can be refactored and published in other systems, such as the Quasi Observations Data Model database, for distribution, for publication in a Hydra server environment. Unfortunately, I missed John's talk last week, but I'd be interested if anybody would like to work on, getting the software to work more smoothly with the Quasi Cloud services. I think that would be a useful thing to understand better. But we did have a very successful demonstration project last year in which we were taking data through the toolbox for processing and quality control and refactoring it on the fly and publishing it directly into a Quasi ODM 1.1 database. So that is a very viable pathway for data publication as well. And another important thing, particularly for local use, is that the harvested data can be displayed and generated on web pages by the toolbox itself to generate little data distribution sites, websites, and dashboards, which are really useful for checking on real-time sensor data. So displayed here is an automatically generated web dashboard where you basically just called this one function in the toolbox to take your processed data and turn that into a web page displaying every parameter, every variable in the field, the last hour, last day, last week, last month, and giving it criteria for flagged and incomplete data to check, and generating these colored boxes on plots to call out problems with an individual sensor. And there are several different views that are supported, and so all of the tools and the style sheets to generate this with one click are provided with the toolbox. We found this very useful for monitoring. We run this with a eddy covariance flux tower that has 75 variables it generates, and we use this to keep track of how the station is working out in the field, and we can bring this up and update it once an hour and get a really good view of the health of our sensor systems. And so there's demonstration workflows and tools and all the supporting files necessary to generate full-featured web pages and data dashboards provided with the software. And I think that's a very effective thing to use for particularly for sensor-based data. But of course, another facet of environmental data, particularly when sensors are involved, is that the data just keeps coming. So you can't just having a solution that lets you kind of interactively work with the data is useful, but a lot of times you need to automate this whole process so it can be run hourly or daily or on some other schedule to repeat this set of steps. That's a very common use case in LTER, and there's some good support in this software for setting up fully automated harvesters where you can use MATLAB's native timers to run any number of workflows on a schedule and process the results to generate various products and reports. So we run a dozen different harvesters on one workstation in a MATLAB instance for our LTER site, and these are also used elsewhere, and it's a very effective way to automate a lot of your initial data processing. And you can start and stop and edit all of these timed workflow operations directly from the Toolbox applications. Okay, so just wanted to cover a few concepts after that little whirlwind tour of some of these capabilities. So these are key concepts that kind of distinguish this software from some of the other choices that are out there. One important one to understand is that every operation in this toolbox is performed in the context of a data set. In many data analytical tools, you're working with, arrays of numbers and text that get pulled out of things, but once you're working with them in that environment, they're really divorced from their metadata and from their context and environmental data. Well, since all passing data columns to a tool in this software transports the metadata as well, and those metadata are used to guide transformation, plotting, and analysis as part of that semantic processing I mentioned. And the metadata also auto-parameterize a lot of the functions so that you can perform very sophisticated analyses with very little input because the data are essentially self-describing. And that's an important facet of this software that really makes it effective. Also, each step along a workflow generates a complete new data set with all of its metadata and processing history intact. So you never have to stop, after running a query, after aggregating data, you never have to stop and go back and write all that metadata or worrying about making sure that all the new data columns you've just generated are described. That's all handled automatically. So just, whether you're filtering to select just data from one station or a time range or aggregating 15-minute data to daily averages, the results of that step is a complete data set that can then be used with the same set of software that generated the primary data. So that's a very important point. So you can either save each one of those intermediate steps as a standalone data set, or you can just toss them as soon as you're done with them and just work on with the final products of the workflow. So that gives you a lot of flexibility and a lot of power without having to waste a bunch of time recreating metadata for each step. Also, every tool logs its operations by date and time, including things like revisions and deletions and flagging, so that you have a lineage for the data that describe everything that you've done with it in the software. Currently, that's just provided as essentially a trace of human-readable trace, like a log of what's been done, but we're working on some improvements to actually let you capture that more as the actual workflow step in terms of the code that was run to make it possible to spin off the actual code to reproduce that part of those set of steps again. But it does document everything it's doing, which is very helpful. And also the metadata in this framework are live, and they're updated automatically. So whether, when you're revising data column, perform unit conversions, add, delete columns, do various operations, the metadata are updated automatically. And when you do unit conversions, equations get documented. When you revise codes, code definitions get updated. And when you merge together multiple data, for example, joining two data sets, the metadata merge as well. So that really, again, this dynamic metadata is really an important feature of the software. Okay, so I've kind of covered a few different types of implementations. I've been describing this mostly this end-to-end processing scenario where you can use this software to go right from a logger right through publication of the data. And that's certainly a viable pathway, particularly for individual investigators or small projects, where you can, basically carry data all the way through the whole data management lifecycle just using this software. But, of course, in environmental programs, there are a lot of good tools out there, things that may provide other features that this doesn't. Or you may just have existing infrastructure that you want to really work with and not just pass away. You want to use this for part of your workflow. So that's also, you can couple this software with a lot of other software to just perform data processing in QC and then connect to those other systems. You can also use this software as a workflow step. Call this using a tool chaining approach. For using other solutions, Data Turbine and Observations Data Model, using this as a processor step in between, or Kepler or Taverna or some other workflow system. So there's different ways that you can pick up pieces of this and use it. So I said this is very suitable for real-time sensor data. It's been used that way for a long time at our site. It scales well, and obviously there's excellent scope for automation that's built in. And since you can has support for multiple formats and protocols for both data formats that it can import as well as export, and different transport protocols, you can use it in a wide variety of sensor data management scenarios. And this is widely used in LTER this way. In fact, we've been actually using this in production for over 12 years now for all of our real-time sensor data at the GCE program. And this is another example of one of those toolbox-generated websites that you can use to distribute your data. Of course, nothing's ever done. Things change, needs change, and expectations change. So we do continue to work on this tool. We're working currently on some metadata model enhancements, improving some of the harvest management tools, and working on a more graphical workflow editor. Currently working, some workflows can be generated by the toolbox itself, but if you really want to set up a harvest workflow, it does require a little bit of working with MATLAB code. We've got some good demonstration files there, but I think there's definitely room for improvement, and that's something we're working on. And we're also, this started as software for one LTER site. It's growing into a community tool. We're considering doing some rebranding to make this a little bit less tied to the GCE LTER program and more applicable as just a more general tool. So here's a list of some of the resources for software support for learning about MATLAB itself, and we operate a software distribution website that has documentation, frequently asked questions, and such. It also has a bug reporting system and feature enhancement system that you can use. The source code is available through a Subversion repository as well as that website, and it can be downloaded in zip files. So as I mentioned, this is open source software, this library, released under GPL license. User support is through a peer-to-peer model primarily. We're not really funded to support the software, but there's a lot of active users. We're trying to build up a community. We have an email list, and again, these interactive resources on the website. And we also are opportunistic, looking for training opportunities to get involved with, so that's something else looking forward to that we're trying to do more of. There's an interactive tutorial that's provided on this website that does kind of walk you through some of the operations. We have some videos on there just showing you how to get started and how some of the system works. So those are some other resources that are available to help get started with this software. Okay, so I think we're about on time ending here, so I'd be happy to entertain some questions here. I'm keeping track a little bit with what's coming in the chat window. So do you want to chime in with any particular questions, Emily, or do you want me to just kind of go through the chat window?
So what we can do now, well, first of all, thank you very much for your presentation. It was great and very informative. So what I will do is go ahead and read the questions that are coming into the chat box back to you, and then if you'd like to answer them from there, I think that will be easiest.
Sure.
So if anyone in the audience has a question, the participant phone lines are muted right now. So go ahead and enter your question into the chat box, and I'll read it back to Wade.
Well, I'll start with Paul's. Yeah, so I saw Paul had a question there about DOIs. DOIs, there's not a direct, DOIs are something that are typically provided through a data archiving system, like, a Data 1 member node or through Dryad or some other system. So there's not native support in the toolbox for dealing with DOIs. That's something that we leave to the actual repositories that you deposit them in. But that being said, you can certainly put, it's a little bit circular, but once you have, if you could get a pre-assigned DOI, you can certainly include that in the metadata along with the data. But that's really more a creature of the actual data repository than the data set itself.
Peter Kirchner had a question. How do you deal with provenance and versioning with dynamic data?
Again, that's something that we do in LTER through our actual the data publishing framework. So you can, like for example, at our site we have a metadata database system that once we've worked up the data and we push out a version using the toolbox and put that data out there, then those files get versioned with a version number assigned by the system. And similarly, when we upload data to Data 1 or to the LTER network information system, it's assigned a data, a version, and that becomes like part of the file name and part of the provenance of that data, actually from the more on the repository end. So again, that's something that we relegate to the actual repository and then instantiate that in file naming practices and other storage that way.
Okay, great. And Amber Jones had a question. Where and how are the data stored on which the toolbox operates, the raw data as well as process data?
Okay, so MATLAB, this is a file-based system. So basically the raw data stay, in whatever form. Typically, the raw data are transported to a file system that MATLAB has access to, either by the user before running it or by the toolbox going out and getting the data. You deposit those raw file on a file system, and then as you are working with that, you're working, in the workflow essentially with in-memory data objects, but at any point along, you can save them in native data structure format as a MATLAB binary.mat file, or you can export them in text formats or others. So it's really flexible. You can essentially store data as files at any point along the way in different formats. So it's pretty open-ended, but while you're working with them, they're basically in-memory data objects, but you can do whatever you need to with them. There's not like a canonical back-end database that's storing them.
Okay, and a question from Ray Brunsting. Could you comment on how manual QA or QC is being done in practice? Who does it, how often, how long, and where?
Okay, that does vary a little bit based on the nature of the data. And in our LTER program, our data management office, we do a lot of the initial quality control. We work with the investigative teams that deployed the sensor to define initial conditions to check for flagging, and then we craft those quality control rules and store them with a template so that just when the data get automatically processed, those rules are evaluated. Then we typically, on a weekly or monthly basis, we'll load those data in. We'll look at the flags that are assigned. We'll bring the researchers in to comment on them, and then we will iteratively we'll either revise rules or do additional interactive flagging, and then the data are reviewed by the actual research group that wanted the data collected. So it's a very iterative process. We have a team approach in doing it. So we use the automated QC as step one. Information management staff review the results and then consult with the science teams in final quality control before publishing.
A question from Lee Hugh. Nice tool. When doing data synthesis, if outside data sets always have their own metadata, do you use the original metadata record or do you trust the one generated by the MATLAB toolbox?
We use the existing metadata when we can get it. So in some cases, from some software programs, all you're really able to pull in are essentially undocumented data. But for example, if we're able to get, EML described data or bringing in data from NWIS or bringing in data from NOAA, that comes in with some metadata. That's preserved and that's maintained and meshed with the data that's generated using the toolbox. So basically the idea is we grab whatever metadata we can, and then that's managed along with the integrated data sets. So that's our approach.
A question from Ian. Can you comment on integration with GIS, such as metadata and propagation of data edits?
Okay, this software is first and foremost designed to work with tabular data, but we do work with GIS in our LTER system, and you can with some helper tools we can, for example, pull the attributes table out of GIS objects and work with them, and we also work with, we can also generate, do some, pull both vectors and raster information out of GIS systems and work with them in MATLAB, and then use the attributes with the GCE Toolbox to do various other, types of operations. And we can also generate geographic, data information in the toolbox and then push that into a GIS. So we interoperate with ArcGIS on a regular basis using the software. But and when it really comes down, we don't really do a whole lot of geospatial analysis in the toolbox, but there is substantial geographic capabilities in the toolbox and the ability to interoperate with ArcGIS.
Okay, and a question from Peter Kirchner. With increasing data rates and granularity, how and where in the data pipeline do you recommend reducing dimensionality?
That's something that that really for us depends on the science questions being asked. We deal with this a lot. We deal with 10 hertz eddy covariance flux data, and we have different consumers for that. So we do some of that data reduction actually by having different programs on the logger that give us different data products, and so we'll process those and provide different types of intrinsic data rates to different audiences right from the logger. But we also what we tend to do is when we do take data, high frequency data particularly, and downsample it for various things, we tend to keep all of those products together. And so we tend to, a lot of times the scientists we work with will want to see that lower frequency summary data, but we tend to produce that as a value-added data set along with the high frequency data and make them both available. So what we do is it's really driven mostly by the needs of the researchers we work with. So I don't have any real general advice other than tracking based on the research questions.
Okay, a couple more questions here. One from Rasika Ramesh. Can we carry out more rigorous analysis involving MC simulations using drop-downs, or would we have to work with the code for that?
Well, you can easily carry out a certain part, like for example, get the data, do some initial prep, and then you can very easily pass data out of the software to pass to some other software for more involved analysis. Like we'll export some things to R for particular types of inferential statistics tools, or you can dump out data for some signal processing in MATLAB. So you can interoperate very easily with other code in MATLAB, or you can quickly export all or selected data as a delimited file that you can load into some other system. So you can. So right now it's fairly easy to extend the toolbox to include your own custom import filters and other things. But you can also, there's a complete extensions module with this software. So you can, if you've designed some pathway for like exporting data to some tool and then running it, you can actually add some entries into an extensions file, and that will show up directly in the menus for the software and it'll let you run that. So you can extend the software to hook up to other things pretty easily. But basically, we don't try to do everything for everyone. We're really just trying to, as soon as we're done working with the data, make it as easy as possible to pass it out to work with other tools.
Great, and Paul Heinrich asks, are there any plans for a detailed GCE Toolbox workshop in the near future?
We had hoped to have one, a participant-funded workshop this fall, but that kind of fell through when we had some staff changes around here. So right now, we're looking at possibilities for a kind of a virtual training workshop that would be more, an informal 1 or 2 day thing where we could, let people come in at different levels of interest or different levels of experience with the software and do a little bit more interactive, demonstrations and help with people using their own data. We had a very successful one in November 2012, but and then also I participated in some sensor training the following spring in 2013. but right now the sources for those workshop funds have kind of dried up. So we're looking for ways to do kind of an informal virtual workshop sometime this fall, and it will be announced on to the email list and to the some of the associated lists through LTER and eco-informatics lists if that does materialize.
Okay, great. We'll take one more question. David Coyle asks, USGS and NWIS will soon publish better FGCD metadata to http data.gov. How can this metadata, a standardized XML format, be integrated within the tool with downloaded USGS NWIS data, such as time series daily values, groundwater levels, etc.?
That would be very practical to do. The approach that we're using for other XML-based metadata is that we generate an XSL style sheet that basically takes the metadata and puts it into a form that's more parsable in MATLAB that we can build into the simple metadata model built in this toolbox. So that's something that I'd be happy to work with you on, basically providing a transform so that when data are retrieved from NWIS, that more enhanced XML metadata gets brought in as well and parsed and then brought in as the documentation metadata. So that's what we're doing with ecological metadata language described data sets, and that's something that we'd be very interested in using to extend the NWIS data mining features.
Excellent. Okay, well, thank you so much, Wade, for giving your presentation today. It was very interesting, and we had some great questions coming in after the presentation. So I'm going to go ahead and post the recording to this workshop on the Quasi website, and you'll be able to access that from the virtual workshop page. And we hope that you can join us next week when we'll have Corinna Greaves and Don Henshaw giving a presentation on sensor management best practices. If anyone has any questions about the workshop today or Quasi's activities, you can contact me at eclark@quasi.org. And again, thank you so much, Wade, for being here. We really enjoyed it.
Good. Thanks for everyone.